Without further, cool. We are recorded. Awesome. So, welcome to our workshop. This workshop is about blockchain development. So we'll dive right into it. We have 3 people presenting from blockchain at Berkeley. So my name is Simon. There's also Grace and Ryan. They will talk for the later half of the workshop.
Hello.
Yeah, cool. So about blockchain at Berkeley, we're a student-run organization at UC Berkeley. We teach decals on blockchain fundamental and developer skills. We also run edX course on blockchain fundamentals, and we consult for companies to create prototypes. Wait, Grace, do you want to switch back?
Like the control?
Yeah.
Oh,
Can you
okay.
go to the previous slide?
Okay. Yeah.
Yeah, awesome. And we also run a startup accelerator with Berkeley Engineering and Berkeley House School of Business to help accelerate local blockchain startups. So yeah, so for today's lecture, we will talk about what is a blockchain, how can a blockchain be used, and what is Ethereum and smart contracts. These are the technical tools behind how do you create a blockchain application and how do you write and deploy a smart contract. So we'll walk you through all kind of steps of how to create a blockchain application that you can do during the hackathon setting. So first, let's talk about what is a blockchain, right? I guess a lot of you might have heard about this, but I want to go into like the fundamental ideas of it. So when people talk about blockchain, you can hear all kinds of buzzwords. It's probably one of those most buzzworthy topic you can ever think of, like Bitcoin, Dogecoin, cryptocurrency. Like, what does it all mean, right? So when you typically talk about blockchains, the immediate thing come to mind is Bitcoin. So what is Bitcoin? Bitcoin is a peer-to-peer payment network, but Venmo is also a peer-to-peer payment network. So what's the difference between like a Venmo and a Bitcoin network? In Venmo, you do have also, for example, I pay Ryan our lunch money. We went to get some ramen some time ago, and we have to go. Even it looks like I pay Ryan directly. We go through Venmo server, and if the central Venmo server is down, I can't pay Ryan anymore. Whereas at Bitcoin network, let's say this is me, this is Ryan, I'll just pay him directly. There's no need to have a central middleman to handle that transaction. So everything is distributed and people can talk to each other individually on this network. So that's like the main difference. So the unique thing about Bitcoin is that it is not controlled by any central entity. And how it does it is through a data structure called the blockchain. So why we want like a blockchain structure is because we want to store a permanent history of everything, all the transactions that happen on this cryptocurrency called Bitcoin. So let me show you how this blockchain data structure look like. So actually it's very visually. You see there's a lot of blocks and there's a chain of them. They're all linked together. That's kind of how you can visualize a blockchain. But what it really is a linked list with hash pointers. These cryptographically hashed objects are linked together. And what this creates is an immutable and distributed ledger. So we'll talk about what is a ledger and why is this immutable. So a ledger is some kind of medium that you store information, such as account balances or who owns what or any kind of data. So from the history of time, we have had a lot of medium of storing data and using ledger to do bookkeeping. And blockchain is one of the type of a distributed ledger. So in this blockchain network, we have a couple of nodes. As you can see, as we talk about in the Bitcoin network example, there's no central authority, right? There's no one node that everyone needs to be able to run this network. So let's say if the gray node is down, doesn't really matter. These 4 nodes can still talk to each other and do things. And you see there's like a blockchain on every node. That's like the exact same copy. So history is replicated across all nodes. So every one has that data of what happened in the past. And to be able to add anything on it, everyone has to agree. whether that's through some kind of voting mechanism or some kind of algorithm puzzle everyone has to solve and agree. There's a lot more details of that I won't go into for the sake of this presentation, but essentially your takeaway could be, anything that added to the blockchain is agreed by everyone on the network, and you can't go back in time and change the history because everyone else has this copy. So if you change something, everyone else knows you changed something. So you can be malicious, but it doesn't really matter because everyone knows what happened in the past. So why this is useful, right? Like what this means is it creates a mechanism to share data amongst parties that ensures data integrity, that data cannot be manipulated, and you don't actually need to trust anyone, right? If I send Ryan money on Venmo, I have to trust Venmo or PayPal that actually that transaction is going to get handled. However, in this kind of network, I don't actually need to trust anyone. I just need to trust the algorithm and the protocol. So that is why this is like a unique technology. And another thing is that you don't put your name as like Simon or Ryan on the Bitcoin network or kind of blockchain network. You have a cryptographic identity. So that's some kind of hashes that represents you. And Ryan will go in depth of that. So let's talk about how a blockchain could be used, because I know this hackathon is about building products. So let's look at some examples of how this data structure could be built, used to build interesting applications. Wait, I click. Cool. Some of the common use cases are obviously cross-border payment. I'm an international student. Sending tuition money to Berkeley is absolutely a pain because I have to go through international transaction. Whereas in Bitcoin, there's really no border, right? I just send to Ryan. It doesn't really matter what Ryan is. This also enables financial inclusion, right? You just need to have a Bitcoin node and you can send values across the network. Using this immutable property, you can track like supply chains of a product, for example, like a fair trade coffee. You can go through every step of a supply chain and make sure the records are clean for that coffee. You can create, using this, since this network has no like one node that like deletes information or adds information that manipulates the data, it's censorship free. So you can make some kind of prediction market using that mechanism. You can also vote on it. You can use this to power energy grids, and you can prove you have the documents across the network. So there's a lot more interesting details and applications you can look into. But also, not all blockchain problems has to be serious. There's also really fun applications like CryptoKitties. You literally put the cats on the blockchain. So how this works is you have the blockchain records the DNA of the CryptoKitties. So they all look like differently. This one is one. That's another design. And the designs are generated based on the DNA of the cat. And you can put two cats together and somehow you generate a new cat. And you own that cat as a token. So that means you own this digital asset on this blockchain network. So that's a really fun game. You can create really unique and cute cats and also trade them. That's a very popular, the most popular game that blockchain has enabled. And what this also means is that your cat won't get taken away, right? This is your cat. There's no central server that can delete this cat. So if you ever played video games before, some kind of assets they kind of take away from you through some kind of game updates, and you just lost it. But here you own that cat from the beginning to the end of history. So I know the same as hackathon is about COVID-19, and I want to give you some ideas on how you can apply blockchain to make applications to combat COVID-19. So this is a Ethereum contract. We'll talk about what Ethereum is in a second, but this is some kind of contract code, some kind of code you put on the blockchain network. And what this contract showed is a bunch of comments in Chinese about memorial. It's a memorial about a doctor that was a whistleblower about the virus in Wuhan back in December or January. And since they put this on the blockchain, no one can ever delete it. There's no like government or entity or social media platform that can delete that information. So this is a kind of a unique use of blockchain that people turn to this platform to be able to send information that cannot be censored. So here I mentioned Blockchain Berkeley work with startups at Berkeley and create help accelerate local startups. So there are a couple that does interesting things with combating COVID. There's one that use Bluetooth and cryptographic techniques to protect user identity for a privacy first contact tracing app. There is one that solves the problem caused by cryptocurrency. Cryptocurrency is very easy to use, so that causes a lot of scams. However, this startup's working with international law enforcement to reveal fraud that kind of relies on selling fake medical equipments. So that's a very good thing they're doing. And another startup is helping patients and doctors and hospitals to share healthcare information without revealing their identity through blockchain technology. That way you can gather a lot more data without a lot more regulation, and you ensures users' privacy, and you have that huge amount of data that you use for medical research. Yeah, so I wanna, before I give it to you, Ryan, I wanna get you guys thinking about how you can use blockchain technology to solve COVID, some kind of, create some applications to combat COVID-19, whether that's like a supply chain track, medical equipment, or some kind of anti-censorship information sharing. Think about how you can combine technology into a unique use case that can be helpful. Yeah, Ryan?
Coolio. Okay. Wait, question about control. Yeah. So before we get into about how to develop a contract for a blockchain, we're just going to talk about this one implementation of a blockchain called Ethereum first. And if we go to the next slide, there we go. So Simon talked a little bit about Bitcoin, which is probably the most popular blockchain implementation, just for keeping track of financial transactions. So at its most basic form is just a way for a bunch of people to agree how much money each of us owns. But blockchain as a technology, it's linked lists. It's a very basic technology that's applicable to a lot more than just keeping track of how much dollars I own. As you see, Simon mentioned, you can put memorials using blockchain, and you can really, at its basic form, just agree on any sort of state among a bunch of people. So in its most general form, we can call Ethereum basically just a state machine. It's a bunch of people agreeing on something in common between them. And so how this whole platform works is that in addition to me having an address, so when I use this platform, let's say I want to interact with Simon, I can send something from my address to his address. Maybe that is a financial transaction or something else. But we can also use what's called a smart contract. And smart contracts are like almost a little person sitting on the blockchain, that they have their own independent address. You can give them money, they can give other people money, but rather than being controlled by a human, they're a piece of code that's running across this network. And what that means is that, like, contrary to a human who might lie, they might tell you, oh, I really gave you the money, but they're just holding it for themselves. The code is being verified by everyone in the network. And so it's verified that if the contract says, I'm going to give Simon $100, that Simon is really going to get that $100. And these agents can be poked in a way. They can react to, let's say, I want to give Simon $100, and the contract kind of wakes up, starts running, and makes that transaction happen. And they can control internal balance that they own. They have their own state that they can maintain, and also can have within the state some storage that they have, for example, for memorials, or just the state of your application that you're building. So Ethereum, again, is just a big state machine where every transaction that you make, whether it's be transferring money or just changing the state of the contract, is changing the global state of the network. And because often most cryptocurrencies, you want people to have some incentive to be on the network verifying these transactions, making sure there's no bad actors, you have to pay them a little money. And so Ethereum has a basic unit called Ether that if you do want to make a payment, then you use this unit of currency. They further divide it if you want, like you can use like Ether, and there's like subunits too. They have their own kind of whole cash system where you can transfer money between people too for financial use cases. And then we're going to be learning Solidity. And so this is a programming language for making these smart contracts. It's not the only one. There's also, like there's one in Rust and probably some other newer ones in different programming languages, but this one is one of the most popular ones and one of the easiest ones to get started with, which is why we're teaching you it. And there's a nice IDE for it called Remix, which we're going to be using in the later parts of this demo. So if you want to just make sure you can load it up on your browser, might be a good idea to do. It's remix.ethereum.org. And this allows you to basically make and deploy smart contracts to the Ethereum blockchain implementation. So then we are going to talk about how to build a bank. So you might be wondering, why a bank? Why not just like some other application? It's because banks they handle money, and a lot of Ethereum use cases do interact with finance. And so this is a good example of an app that will allow you to view a state, which is how much each person owns and their funds, and also be able to interact with the contract, depositing money to the bank and withdrawing from the bank. So we'll start off in Solidity. If you want to make a contract, you use this contract construct. It's like a class almost. As you can kind of think of an analogy as this whole contract is going to be very similar to like a JavaScript class. And so we give a contract a name, and then we can put variables inside of it. And so you can use, for example, many different data types. Here you do have to specify the data type. It's not exactly like JavaScript, even though it's based on it. Here we have a uint, which is basically just an unsigned integer representation. For example, this is very good, for example, for storing money. And then we have an address field. And we'll talk about what addresses are in a bit, but it's basically just a way to identify a person on the chain. And so this contract will keep track of the owner who created the contract. And then we can add functions by doing this bit of crazy little things after the function name. You can make both public and private functions. Public just means that other smart contracts can call you a smart contract. And so if you make a contract that you want people to build on, for example, there are examples of contracts which call other contracts, and you can get this globally interaction within the Ethereum ecosystem. Or you could just make it private, which means you're using it yourself. Balance, you'll notice, uses the view keyword, which means that we're only going to be able to view the blockchain state by this function. We don't want balance, for example, which is just going to return your balance to the bank. We don't want that accidentally like transferring funds to people, changing the state of the blockchain. It's just a thing that reflects the state of it. And then constructor. So when you create a contract, you often want to initialize these variables. We did this with example integer, but if you want any more complex logic, you can put that inside of your constructor. And so in a constructor, what we want to do is we want to figure out that owner variable, which was a few slides ago. That's who created the smart contract. We want to populate that to an address. And so maybe wondering, what exactly is an address? Well, so in traditional finance, if I send, let's say I'm sending Simon a check. On my check, I'm going to have to put a few items. The bank will want like a routing number, an account number, and I'm going to name my check number, but that's not dependent on Simon's address. But we identify, for example, a bank by a few numbers. Very similarly in Ethereum, each person on the network will hold their own address. And so this is just a long string of numbers which are derived from, if you want to be very cryptographically specific, it's derived from the private key that the person is using to sign their transactions. But this is just a big long identifier that only Simon will be able to use. And so if Simon sends me his address and I will send something to that address, I'll know it'll be to Simon. And I mean, also since these are long, people often represent them with QR codes, but very often they're just hexadecimal characters in a big long string. And then this is another example. This is the address of a smart contract. So you'll see it's kind of tiny, but under 2, it'll say like contract, and that's the address of the contract. So every contract on Ethereum, much like a regular person, also has its own address that if we want to call functions on that contract, we're going to need to use that address. So when this when this contract was initialized and deployed to the blockchain, we can use the message.sender field to keep track of the person who created it, and then we can save that inside the contract in case maybe in your contract you might want to grant that person special admin permissions, or let's say a lot of contracts, since if someone needs to update them, it's stored on an immutable blockchain. So you might be wondering, like, how do I update my contract if it's on something immutable? And so what a lot of people will do is they will have a mechanism where the person who deployed the contract has special admin privileges to point the contract to a new contract to update the state, basically saying I'm the old contract, here's the new one, and direct people to use the new contract. And then, since this is a bank and we're going to want to keep track of how much each person owns, we're going to use a dictionary for that purpose. And so use this with the mapping keyword, and it maps basically one type to another type. In this case, it's going to be addresses to UINTs. And UINTs, as I said, are very good for storing money. And so we're going to make this balance one. And like JavaScript, you can access it with brackets to get. And in this case, message.sender is not going to refer to the person who made the contract anymore. It only does it in a constructor. In any method, it's referring to the person who called that method. So if I get my balance as message.sender is going to be my address. And then withdraw. For this function, we are going to want to give me money. And so we can use the message.sender.transfer function, which takes money that the contract owns. So it's like the bank's internal funds and gives them to me. And so I'm going to be taking some amount from this contract and taking it out, minusing it from my balance, and then giving it to me in my own Ethereum funds. And so this contract, it does have one problem. So just wondering, like, does everyone in chat have, if you look at this code, think about like the bounds we might have on withdraw amount or any conditions. And can anyone think of any possible issues we might have from this code statement if, let's say, I withdraw a lot of money? Oh, gas fees. That's okay. That's another topic. Yeah, exactly. It's a good point. So you could withdraw more than what's in your balance. So if we withdraw, like, let's say $1 million and I only have $5 in my bank, my balance is going to go really negative. And that doesn't really happen in a bank. Banks don't like usually allow you to go negative balances. And so in this contract, we're going to want to prevent that from happening, to make sure that we're not taking negative money out and giving people more than what's at the bank. And so we can use a require statement for that. And so this is kind of like an assert statement, almost like in a testing framework. It'll throw an error if the condition that you put in is false. And so we're going to require that what you're withdrawing is less than what you have at the bank, or less than or equal to, just to make sure that you don't withdraw too much. And then finally, we need to figure out how we give people money from the bank. And so, actually not give people, how people put money in the bank. And so if I want to, let's say, deposit $5 at the bank, I'm going to need to give some of my Ethereum and put in the bank. And so Ethereum started requiring some people who are accidentally giving contracts money, just a little statement called payable that makes sure that your function is going to actually use the money that people put in it. And so it's just almost like just a debugging tool to make sure that we don't accidentally call the wrong function and give money to it. And so for a deposit function, we're going to need to use this payable keyword, and then it'll take what message.value, that's the amount of money we're giving to this method, and it'll increase the balance by that, and then just tell you how much you have. And so under the hood, Ethereum, like whenever you send money to a contract, it'll handle putting the money in the contract and all that good stuff. And all we're in charge of here is just updating our total contract state to reflect that you put money into it. And that is it for the contract. So now Grace is going to walk you through how to deploy this thing.
All right, so in order to deploy these smart contracts, we're going to need to have our Remix IDE and MetaMask. So basically, MetaMask is a Chrome extension that allows access to Ethereum-based dApps in a browser, and it allows you to create and manage different identities and accounts. And it's basically an interface for accounts and transactions. And when testing with MetaMask, there's no need to run an actual Ethereum node if you use a test network, which we're going to do, because running an actual Ethereum node takes a lot of computational energy. Okay, for some reason cool. All right, so here's an overview of what the demo is going to look like. So we have our IDE and the contract on the Remix. And before we can deploy the contract, we have to compile it. And it's important to make sure that our compiler version here is at least whatever version is specified in Pragma Solidity. So in this case, we're going to want to do all compilers that are greater than or equal to 0.4.25. So, and then we're going to want our environment to be injected Web3 because we're going to be using a test network. And once we have our environment and it's compiled, then we can click deploy. And then once it's deployed successfully, you can see a list of deployed contracts at the bottom left corner. And then if you click on it, you can see all the functions that you can use with it. And once it's done, and once transactions are made, you can view them in your transaction history in your MetaMask account if they change the value of your current account balance. And then here's some other transactions that are displayed in the console. All right, so for the contract that Ryan was presenting just now, basically it's a bank that has three main functions: deposit, withdraw, and balance. And we're going to deploy it to the Remix ID and use MetaMask to demo them on the Robson test network. Okay, so here's the contract. Yeah. So how do I move? Okay. So now we're going to go into Remix, and before writing any code, our environment is going to be Solidity. And then paste the code in here. All right, now we have our code and it is ready to be compiled. Yeah, gotta have our environment, and we have our compiler version, which is the right one. And so and yeah, we'll compile calhacks.sol. All right, now it's compiled and we can deploy it. And in this case, we're going to want to do injected Web3 and actually have a MetaMask account that's already up. And so I'm going to do mine. And so when I deploy this contract, it'll show up in my transaction history. And as you can see, the account address matches mine. So yeah, let's deploy it. This does take a few seconds to have transactions appear in MetaMask, but yeah. And it's confirmed. And we can view it on Etherscan as well. It's pending, but all right, let's just go back to Remix first. All right, so now that we deployed it, let's look at all the functions that we can use with it. So let's see who the owner is. It's just my account. And then our current balance is 0 at the moment. So let's add some money to the account. So in this case, we're going to want to specify the value over here before clicking on deposit, because we're going to be using money from our MetaMask account. So I will deposit 1/1000th of an Ether, and then get the approval through MetaMask. It'll take a few seconds, but yeah. it's currently pending, but as you can see, we have the deployment transaction already recorded in our account. And then it's now showing on the Etherscan website as well. And we have the hash, the status, from and to, value, and the gas fee. All right. It is still pending. Okay. Yeah. All right. Balance is still okay. Yeah, so the transaction is now confirmed and our balance should now not be 0. Yeah, so because UNT 256 is a different unit than Ether, it's gonna be a different value than what I deposited in terms of Ether. But yeah, this is our current balance. And then this is reflected in our MetaMask, which got now decreased by 1,000th. So it went through successfully. And now let's withdraw some amount. So let's withdraw maybe half of this. And there's a lot of zeros, so I will save that. And then when I call withdraw, it'll ask me to confirm it again through MetaMask. And also, since all these transactions where I need to confirm via MetaMask, it's asking me because they're directly affecting my account's value. And so calls to owner and balance don't affect the account value. So I don't need a confirmation of the transaction. And so it won't appear in my transaction history, just an aside. And still waiting for it. All right, while we wait for this function to be approved, let's try withdrawing more than our balance to see if this contract is protected. Yeah, so because this balance is greater than, because this amount is greater than what's in our account, it's not going to work. Right. All right, both of them are still pending. All right, so as you can see, this recent transaction failed because there is not enough money to withdraw from. And since we withdrew from our balance, let's see what the balance currently is. Yep, and it's successfully updated. And then this would be in transaction 2. And since we added half of what was deposited, it got added to the balance. And that is now reflected in our account. All right. And yeah, and then if you were to look at transaction history in the console, you can see that all these transactions are displayed, and you can also debug transactions that might not have worked. So yeah. All right. Okay, so that's basically it for the demo, and I'll hand it over to Simon to discuss other blockchain tools. You present.
Right. Gonna request control, yeah.
Yeah, okay.
Okay, cool. So we're gonna go back to the slides. Awesome. So you saw a demo of how to deploy like a sample contract through MetaMask and remix and put on the Ethereum network. So we had did the live demo. So for your hackathon project, I guess we're halfway in the hackathon, but if you want to do something with building a blockchain enabled application, this section will be really helpful. So first, let's talk about what is a Ethereum powered app. So a traditional web app like Facebook or any kind of web app, you have web server, you have your web browser interface, you have JavaScript, and you have a server that connects to the database, and this is all hosted at one place. Whereas for Ethereum application, because of blockchain and replaces that kind of centralized database system, you have different instances that are talking to each other, and the data live in the Ethereum space. And whereas this, like your typical JavaScript calls, it doesn't like connect them automatically as easy as intuitive as a traditional web app. You have to use some kind of framework called web3.js to do something called remote procedure call, to call from JavaScript and to able to interact with the Ethereum blockchain. So we'll go into that and how it works. So this is kind of like the stack usually to build some kind of blockchain application. You have to have some kind of user interface, usually building React or Angular if you prefer that. You have a web server running, and usually Node.js and Express. That's the easiest way to do that. Then you use Web3, this remote procedure call, to interact the web app to the Ethereum blockchain. You might also have a MongoDB to store some other data like assets or some kind of user system, but you don't need to. So that's kind of like the stack of a typical blockchain application. It's also called DApp, decentralized application, because there's no one central place of database since it's on the blockchain. Yeah, so CryptoKitties, as we mentioned, was a DApp. So Web3.js, as I mentioned, is how do I connect the web app to the Ethereum blockchain and interact with it, and that's a remote procedure call. So you can interact with the functions, you can deploy contracts, you can send data, you can query the data from the blockchain, you can do a lot more things with it. So yeah, that's Web3.js in a nutshell. You can read more about the typical functions that you need to use. We have some tutorials at the end, so you can look into that. So another thing about developing on the blockchain is always ensure that you're deploying on the test network. That way you don't actually need to have Ether, because Ether is actually quite expensive in US dollars. You can get like fake Ethers from the faucets for these test nets. And also it ensures once your contract is deployed, it won't get like, if it gets attacked, you won't like lose any like Ether. So this is a good way to ensure you're developing safely and also with enough Ether to be able to support that development. So some of the core dev tools you need, right? We talk about MetaMask, how you go from your contract and connect that to your wallet. You have the remix ID where you usually write and compile and deploy your smart contract. These tools are usually for more advanced developments. Truffle is kind of like a framework that can get started with some kind of decentralized application really quickly. So it might be good for a hackathon setting. Not just more for like local testing. You probably, if you want to demo it locally and without that much, you see the MetaMask, that took like a long time to confirm. If you want to confirm really quickly, you can do this. That's a little bit more advanced. And Infura is it's an endpoint provider that you need for your Web3, the remote procedure call between your web app and the Ethereum blockchain to work. We'll have some tutorials about that as well. Some more advanced tools that are not necessary, but you can think about how do you kind of apply in your blockchain application, or for example, a file storage system that's distributed. And this tool, Pinata, actually help you facilitate it very easily. OpenZeppelin has a lot of template smart contracts. So you can like literally use a lot of their templates and that are very tested securely and quickly hack out something. Interledger is a way to send payments across different ledgers between, let's say, Ethereum and another blockchain. Actually, I think Puma browser, one of the sponsor, they have a challenge hack and like they have a category prize, and I think they use Interledger. 0x API is for for you to build like your own exchange to kind of trade from one asset to another. We also have some demos about that. Okay, cool. And if you want to continue your project afterwards, these are some more like advanced frameworks that are usually used in enterprise adoption and also used for some kind of a permission blockchain network that some nodes have more authority than others. It's not like a true kind of a definition blockchain, but a lot of enterprise like to use this. So kind of just like let you know these exist, and these are used in the real world. So some kind of resource you can get started hacking. Here are some documentations about like web3.js, the syntax, what are the best way to write smart contracts so you don't get hacked. But for hackathon setting, I don't think that's as important. If you're not sure about some blockchain concepts, you can look at this link. And a lot about the technical details and different aspects of how to develop blockchain application you can find in this website. And then we have like topical reviews and sample code for each. I highly recommend you start with the Ethereum Studio the app tutorials. It provides you some kind of skeleton code for very self-explanatory, and you can easily hack something up on this boilerplate code. You can also look at our tutorial to how to make your own token or cryptocurrency and how to make your own decentralized exchange. There are some more coding exercise here, and you can also use Truffle, the boilerplates we mentioned before. In addition, you can get your fake Ether here from this testnet faucets. It's pretty easy, just like one click, wait for 10 seconds, it will get like fake Ether. So that's about it for our recommended resources. I want to leave some leave some time for questions. So if you have any questions, please feel free to raise your hand or type in the chat. And we can unmute you if you have a question. Yeah, we will post the slides. I think the CalHacks people will post it. I can also just post it here as well. So I think I just posted the slide.
Okay.
Yeah, no problem. Yeah, so any more questions, we can take a few. Yeah, we also be uploading a recording of this. So if you missed the demo part, we can show you that as well. And also, what ways would you recommend to query the blockchain for particular data if we don't have the transaction hash? So do you mind elaborating on like the purpose of you doing this? Like what kind of application you're trying to build? Maybe Ryan, you can also chime in on this.
And generally, if it's like an Ethereum contract, you want to get the data. That's not, you just need, all you need is really the address of the contract to get the data from. Although if you do need to get a specific transaction, you'll of course need the hash.
I think on some like Ethereum Explorer, you can find the transactions associated with the contract.
That's true, yeah.
Yeah.
But I think we showed like Etherscan is really good for debugging and seeing what transactions you've made and all the hashes of those.
And also like for a hackathon project, I recommend you just like testing locally and like maybe have a couple of nodes and just test locally, maybe in Ganache. You don't really need like a lot of that data to be able to show that works. You just try to hack something up really quickly to show a concept. All right. Well, still got 5 minutes, so if you guys have any questions, we'll stick around here. You can give any info about careers in blockchain? Like, I guess as internships or like full-time job. I mean, this is a very new industry. So like a lot of companies that just started. There are startups, a lot of blockchain startups doing interesting technical work. There are also larger companies such as Facebook, AWS, IBM, JP Morgan. They all have their blockchain division. So there's a lot more opportunities, and it is a very, very new industry. What are the pros and cons of public versus private blockchain? Public blockchain is that, like Bitcoin is a public blockchain, right? But for example, if JP Morgan decides to implement some kind of internal blockchain system, they probably want some permission to be able to edit information or add information. So that they kind of make that private blockchain. Some people will argue private blockchain is not a real blockchain, but that's kind of a lot of the enterprise are using this private blockchain internally. Do you think most of these blockchain companies are viable as their product, or kind of are they like sketchy as a company? I think a lot of the products are very promising. A lot of the technology is still in the early days. You can think about it, this is like the early days of the internet. So there's a lot of explorations, but I think it's a promising field. A lot of really cool work are being done. Ryan, do you want to answer Dan's question?
Ooh, okay, let me look. Particular field. Yeah, so that's very specific to how you implement your blockchain. So if, for example, if you're just making, for example, a contract to store a bunch of data, you'll often just be using like a mapping. Although Ethereum mappings don't tell you like the list of keys that they have. So I mean, if you have a mapping, you could like query. I mean, probably typical use case, if you know the key that you want to query, you can just do mapping at like key. And if you're also using like Web3 in your application, you can use that similar syntax to get a key. Although again, a lot of this is very dependent on the way you write your contract. If that helps. I don't know, that was not very vague.
Yeah, and Ryan, I think I replied to the question previously in the chat. If you want to expand on that.
Which one?
Any on the query question. Let's say we store a bunch of fields in a block and we later query the blockchain.
Yeah, as I was saying, it's very dependent on how the contract is called. Yeah, as you said, I mean, Web3 is a good resource for looking into that and debugging a contract.
Yeah, Web3 is pretty useful for a lot of very easy interactions with Ethereum. I recommend you use that for a hackathon purpose.
Oh, and for the question about whether you know if an address is a contract or not, I believe, correct me if I'm wrong, Simon, but I think that you do, like when you deploy a contract, it does have a special field specifying that it is a contract so that it can run its code. And that if you're using like Etherscan, it'll tell you if certain addresses are contracts or not.
Yeah, I think Etherscan tells you that. You can tell the difference. Cool. Any more questions? We got 1 more minute.
So yeah, to answer that question, there's a way it'll tell you, I think. Yeah, it'll tell you like next to an address if it is a contract call. I'll probably screenshot this.
Yeah, if you want to learn more about these topics, I highly encourage to go to our website. We have a lot of resources to help you get started. And there's a lot of like Medium blogs and GitHub repos that show like sample codes and how to quickly get started. So these could be resources as well. Yeah, so I put our website in the chat as well.
I screenshot on this. Okay, there you go. Etherscan is a pretty cool website just to see like what's happening on the Ethereum network. So you'll see here all these little icons. These are transactions with contracts, and like this one's to a user. But for like some of these, for example, people have published the contract code to here. So if you do want like examples of like blockchain applications in the wild, here is a particular implementation for this contract that was uploaded and verified.
So you can find a lot of information on Etherscan. And Also, one of the sponsors wanted me to pass it along. Puma Browser, which is past one of our past accelerator company. They are having like a category prize. It's pretty cool. I think you get some prize with it, and the founder is willing to help in anyways. So feel free to check that out and talk to him. Yeah, I think that's it. I'm gonna see if Ristik's still here. Cool. I guess we'll just end it. I think I'm on Slack if you want to pay me. Thank you guys for coming to the workshop.